Okay, so now it's time to take the different data parameters we explored in the previous videos and begin to utilize that information to manipulate geometry, kind of one of the main purposes of the use of parametric modeling. So we're going to use a couple different parameters to adjust multiple characteristics of these geometry. And so we're going to actually shift into more of the 3D workspace. The previous ones just kind of looked at basic grids and curves, but now it's time to kind of get into this three-dimensional space of Rhino and utilize some abstraction to show these transformations. So we're going to keep with using a grid, but we are going to use a 3D grid of points now to really kind of take advantage of some of these transformations. So we're going to approach the grid a little bit differently. You can use the script from earlier to create that 3D grid, or you can utilize this method to create another type of set of points. So in this case, I'm going to reference this curve. I'm going to then convert it to a surface. And another way that we can create a grid of points from a surface is going to our surface category, utility, and divide the surface. So we're basically going to divide this into a series of points. I'm going to keep the size reasonable because, again, it's going to generate a lot of points and I don't want it to get too busy either. So again, this is the simple process of essentially creating segments of points in both directions. So even though there's 5 listed, you'd think that there's just 5 points in each direction. It's actually segments. If I look at the space between the points, I can see that there's 1, 2, 3, 4, 5. So whatever this value is, it's always going to generate one extra point to designate the end. So there's the start and the end and all those in between. But we're going to use the same series of components to make it 3D as well. So again, I'm going to flatten this to essentially put all these points in one pool. I'm going to move them in the Z direction. But again, I want to have them going in the same intervals in the Z direction as they are in the Y and X direction. So I'm going to, again, create a range. So set, sequence, range. And again, I want it to go in this case, because this is a 15 by 15 square, I'm going to hit 15. Then I'm going to use the same slider that I have for my U and V count as my number of segments. Go ahead and plug that into there, and again we need to graph to this to make it a 3D set of points. So let's just go ahead and turn this part off. You can even turn this off as well. So we're going to use this to take advantage of some of these transformations. In this case, we're going to look at how can we create different size of geometry based off of a relationship, a color gradient, and geometry. Again, we looked at about 6 different parameters in the previous exercises altogether to generate different types of data. In this case, we're just going to focus on the relationship between the distance of this group of points with several random points that we will place within kind of the bounds of this area to get a better idea. So what we also want to do is, like I said, add a couple random points. So I'm just going to stick with 3. I can take them if I have my gumball turned on. So you can see this kind of gives you a little more control over this. I'm just going to shift this one to be up here a little bit. This one maybe somewhere in the middle, and then this one a little bit towards the end. Again, what's great is that we'll be able to change these throughout the script and have everything respond to it. So I'm going to take these 3 points. and place them in here as well. And again, just like the previous scripts, I'm going to use the distance or the closest point to essentially start to separate these out between their respective points. So I've got my points here. I'm going to go ahead and flatten that so they're just all kind of being treated equally with this. And again, if you want to see what that starts to look like, this is just a visual. It's not really part of it, but it just gives you a better understanding of how this is working. So it's essentially taking those 3 random points we place in there with our grid and kind of separating them that way. So from here we can use this distance, which is what those lines were representing, to create different sizes. And we'll get into a lot of different ways in which we can interpolate this data, but for now we'll just essentially kind of create a very simple function to do so. Basically, you can see that when I'm looking at these distances, I can see some pretty high values of 8, 9, 7. I don't really want those values to have a direct relationship between the shape, because that's just going to look way too big, and you'll see what I mean in a moment. But we're going to slightly adjust those values so that there's not too much conflicting geometry. Again, it'll make a little bit more sense in a little bit. But basically what we want to do is say that the closer these points are to those 3 random ones, the smaller, and then as it gets further, that geometry gets bigger to kind of represent the distance between these points. So in order to do that, I'm going to take my grid of points and assign a geometry to them. So we're just going to play with one type of geometry and adjust its size. So let's go to our surface, freeform, or sorry, primitive, and we're just going to create a sphere. Okay, so I've got a sphere. It's got a default radius of 1. It doesn't look like it's going to intersect too much with it, which is good. So we can use that as kind of one of our parameters. But I want to essentially make all these points become a sphere, right? So now I've got, instead of just a grid of points, I got a grid of spheres. But again, I want their radius to not all be the same. I want it to reflect that distance. Like I said, if I just directly plug this relationship of distance between these points, it's going to create something pretty crazy, right? Like I can't really tell what that's doing. But if I were to take a fraction or a percentage of that distance, they're all going to be, or they're all going to still have a linear relationship, but just at a smaller scale. So what I can do is, again, go to math, multiplication, maybe multiply it so that they're a quarter of that. That's probably still too small, but we will start to see a better kind of relationship of that. So let's just drop that a little bit smaller, right? So now we can start to see how some of these spheres that are further away from our main points are much bigger than the ones that are immediately next to it, right? So again, I can take these points, and as I start to move them around, the size of our spheres begin to change as well. So now that I don't have a lot of points over on that side, like they're all pretty much over on this area, you can see that these ones, because they're getting so far away from those, they're going to become much bigger. So it's an interesting way to kind of start to explore this relationship between size and distance of objects. So that's one way we can start to, again, use the parameters of distance to affect different size of objects. Obviously, it doesn't just have to be spheres. You can see that there's all sorts of different geometry that you can use. So if I want to use a box on center, so you can see that I can play with a lot of different values. So if I want to, I can just do this and then use, if I want it to truly be like a cube, I just plug this one into all three of those. I'll turn that one off. Now you can see we have cubes. These are all 3D shapes. If I want, I can even just do simple geometry as well. So let's say I want to just do circles. So again, I'll just kind of show you that these are all the different ways. This is going to be very much like the sphere, except it's just a circle. It's going to be on whatever that plane is. So in this case, it's on the XY plane. If you want them to go in a different direction, you can see that it's asking for a plane. So I get a vector. Maybe you want them so that they're facing you in this case. So if I do X and Z, can again use the point as my origin, plug that into there, I'll turn it off, and now they're facing me, or they're facing towards the camera. So these are all different ways of doing that. So it gets pretty interesting when you start to change the scale or size of objects in relation to that distance. So let's shift over a little bit more and let's just kind of continue to develop this. I'm going to basically just take this part of the script, since it's going to be the same thing for each one of these sections, except now I want it to be in this area. So I can select that rectangle and replace it in this curve. So set one curve. So now you'll see if I turn this on, I've got my 3D points here. So let's look at something else. Maybe we want to use color. And let's just look at color for now. Let's not necessarily look at the other things, but we can begin to play around with some type of geometry and associating a color where we don't really have to use the distance to change the shape or the size, but we just want to use it to do the same idea with the color. So again, I'll actually copy, or let's just go ahead and repeat it. So we'll put some more random points in here. I'll just move them at all sorts of different levels or elevation. Okay. Maybe this is somewhere over here. There we go. So again, I'm going to reference those points. Go back to vector, closest point. And again, we're going to use the distance to dictate the color of an object. So in this case, let's actually use a cube instead this time. So let's go to our primitives, center box. And again, we could begin to translate it to them responding to that distance. We'll get into that a little bit later of having multiple effects going on. But for now, let's just give them all a fixed value of something like 0.25. Maybe we'll make them a little bit bigger. Alright, so now here's our cubes with those 3 random points. Again, we're going to use the distance to dictate the color of these objects. And the easiest way to do that is to go back to our parameters, input, and use a gradient. So basically, as they get, again, the closer they are, it's going to be one end of the spectrum, and the further, it's going to be another spectrum. You can see that's asking for a couple things. It needs a lower limit, an upper limit, and then all the data. So the distance, this is pretty much what's we need to put in for our t values. But it needs to know, okay, what's this essentially domain of values? So what's the closest point versus what's the furthest point? So we can use this and a series of domain information to do that. So I'm going to go to domain. I can look at the bounds of these values. So it's going to tell me the closest distance and the furthest distance. So 1.15 and 12.77. These are the values that go into there. So the lower value, 1.15, goes into that one, and then 12.77 goes into there. So this is asking for two inputs. This is just giving me one output. So I actually need to deconstruct this. So I can stick with here, domain, deconstruct domain. And the way it's going to work is it's going to take the lower value, is going to be in this pink spectrum. The higher value is going to be in this more richer red. If I right click on this, I can look at some different presets. So you can kind of use it like a temperature map. So again, the closer, the hotter versus the further, the cooler. So now I can go to display, do custom preview. So the geometry is what it's first asking for. I can go ahead and turn this off. And then it's asking for a shader or the color. In this case, I drop this into there. And now we have it working so that the ones that are really close to this point are red, versus as I get further, they're cooler. If you want, you can even do the opposite. Let's say you want it to be this blue for the closer and then red for the further. If I just switch these, now I've got that as my results. We can even start to give it some transparency if I want. So maybe it goes from something that's transparent to something that's more solid. So what if I begin to take those red values and start to change their alpha values or transparency. And you can kind of just eyeball it to give it some fluctuation. But you can start to see how the reds, they're kind of a little bit more hollow looking versus the more opaque colors. The thing to be aware of too is that different types of geometry is going to represent a little bit differently. Because these are essentially B-reps or surfaces, they're going to kind of keep this wireframe. If you want it to look a little bit cleaner, we can actually convert this box of surfaces into a mesh, and it'll look a little bit better. So I'm going to go to the mesh area, then I'm going to convert from a B-rep to a mesh. So I'll just drag that into there. We'll turn it off, then I'll drag it into there. Now you can see that that wireframe is gone and they look a little bit more crisp. So that's how we can start to get some color to it. The next thing we want to do is this very similar where we're going to, again, use pretty much all of these same pieces of creating the grid and the relationship of distances and rotate an object. So again, I'm going to reference this as my new curve. There's my points. I'm going to create another random 3 points or so. And just so it's easier to see, we'll use just a simple square to show this rotation value. So again, I'm going to look at these. I'll go to my curves. It's a little bit difficult to see a circle getting turned, but we can even see a polygon. Let's try that one. So we'll apply it to all of these. We can determine the radius, so essentially the size. So let's do something like 1.5. Might even make them a little bit smaller. The number of segments, so we can have them have a certain number of sides, so I'll just keep it at the 6. And then there's a fillet radius. We just want to keep that as a hard edge. So again, we can use these distances to rotate it. So we're going to go into a little bit additional area of this area. So if I go to this section, we can see that there's a couple different ways we can rotate it. We can just simply rotate these on a plane, which will keep it pretty simple. So I'll take the geometry and plug it into there. Here's the angle, and then it also needs where it's rotating from. So the points are where I'm rotating it from. And now I just have to determine how much do I want them to turn. Again, I can use this distance, which is in feet, and just treat this as angles in degrees. So this again is looking for radians. So I can go to math, trig. I can either convert an angle in degrees to radians, or I could just right click and say treat these as degrees. And now I'm going to turn that into there, and I'll turn off this original one. And it's a little bit difficult to see. If I go to the top view, you'll see that they start to rotate a little bit as we go on. If we want to kind of magnify that rotation, let's actually try let's actually just, instead of 6 segments, let's just do 4, so it's a little bit easier to see. And let's just, again, kind of magnify this angle of rotation, because they might not be turning that much. So let's go to math, multiply it by maybe something like 3 times the rotation. Right, so now we can see a much more dramatic turning radius based off of those distances. Starts to look kind of interesting on the top too, where some areas don't seem like they turn a lot versus other areas have a lot more turning radius based off of those. So here are just 3. I guess it would have helped if I actually used the correct points. So let's try it this way. There we go. So now they're much more representative of those points. But again, it's great because you can just start to move these and they'll rotate again depending on that. So these are just 3 different ways of how you can use those parameters to transform geometry, whether it's the size, color, or rotation. And you'll start to see it in the next video. We'll show a couple more, and then by the end, in the next video after that, we'll start to see how you can begin to combine all these transformations. So you'll see changing of size, color, and even rotation or overall shape.